Is my audio working? Man, I don't know. Let's try this again. Activate, deactivate. Don't know why. Sure, that works. Welcome back, everybody, to another Binary Ninja live stream. We have something a little bit different going on today. Oh, there's a fuzz hanging on my headphones. Um, we've got Brandon is going to be joining us, and I don't know if Brandon's been on this stream before or not. This might be a first time, or maybe I'm just misremembering. I can hear him, but nobody else can hear him. So let's see if actually let me switch back over and see if we get him in here. Hello, can you hear me, Brandon? Can you hear me? I hear you. I hear you, but I need to tell you one thing. I think I know what happened. Da, 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 da. So can you hear me? Can you hear me yet, Brandon?
Yeah, I can hear you.
Okay, there we go. I can hear you. So let me see. Okay. I'm still transmitting. All right. I think when I started the stream, it ate my audio to you. So welcome. People have been able to see you. Thankfully, you didn't pick your nose too many times. So we're fine.
Oh, we're live right now.
We are live. Yeah, everybody's here. So we've got your screen up. We've got you up. We got me up. Um, yeah. So I was trying to remember. I mentioned earlier before I flipped over to your view. Have you been on the stream before, or is your first time being on the stream?
This is my first time on the stream.
It's exciting. All right. Very good. So yeah, I didn't even think about that when I asked you, but that's kind of nice. Let me know, by the way. Actually, go ahead and say something, Brandon. We'll look at our levels.
Test, test. Can you hear me?
Yeah, okay. I think that looks pretty good. Audience, let me know if it's off. I think actually my audio is a little light relative to him, but hopefully people can hear us. That's fine. If people can hear you better, that's the more important part. Just want to talk about. So I'll set the stage a little bit here. We're gonna be showing off a couple different new features in Binja that have landed lately, and a couple of new things that aren't quite yet on lately. So the main thing I was gonna have Brandon come on to show. Actually, I didn't even warn you about this, but do you want to do the base address detection stuff first?
Yeah,
Do you got something
yeah,
to?
we can do that. I threw a few binaries into a folder just in case. So yeah, we can start with that. I think it's probably easier to demo that outside of a project, but then open for triage.
All right, so I'm gonna go ahead and boost my audio a little bit here. And all right, let's pull that high. So I pulled mine up a little bit, pulled yours down a little bit. We'll see if we meet in the middle. It's a little weird because I'm like off. I'm not used to looking at the other screen. This is nice. I don't have to drive. The good news is I can provide the commentary while you're clicking. So usually I have to both like talk about what's going on and I have to drive the mouse and keyboard. It's kind of nice when somebody else can cover it for you. So okay, so this is a triage view, right? And
Yep.
except
Yeah.
it's
So
got some
this
new
is
stuff.
triage view. This is where the widget is integrated into the UI. So first of all, it will only show up if a mapped view is rendered. So if you load an L for a PE and you go to triage view, it's not going to show up under the assumption that if it's one of those file formats that the base address is well told to you by the PE or ELF header metadata, and that Binary Ninja is going to be able to load it. I have found a binary here recently that isn't the case, and it was a PE formatted Linux kernel image on Android where the base address is set to 0, despite that it is position dependent and does need base elsewhere. So I do plan on updating this such that you can run it on other file formats that aren't raw binaries as well. And it'll also be a really good source of information for testing. So yeah, so if you load a raw binary, U-boot bootloader is across different architectures is primarily what I've been using for testing and development. And then you navigate over to triage view, you'll be presented with this base address detection user interface. And the two settings that matter the most are the architecture and the analysis level. For the most part, Binary Ninja is able to auto detect fairly well across most binaries.
Now, is that the
Where
same auto detection that, like, if I open the binary in the first point, I've got that open with options dialog, and there's that drop down there. Is that the same auto detection algorithm, or is there a different one?
Yes. Yep. Yeah. Basically, what this does on the back end, the load API, the options parameter, one of which you can set the platform. And if that platform's blank, the load API runs the auto detection, and it's the same auto detection that the open with options would run to pre-populate the platform. And so, really, like the auto detection does fairly well. The only corner cases that I see are certain architectures like RISC-V, for example, 32-bit and 64-bit RISC-V. There's really no difference in the encoding on the instructions. And however, like the 32-bit or 64-bit very much matters for base address detection because of pointer widths. So what I have noticed is Binary Ninja likes to recognize 64-bit RISC-V binaries as 32-bit.
32-bit, because the encoding doesn't really give you a difference. The byte frequency wouldn't give you a difference, but the immediate pointer values are what would actually have changed. That makes sense.
Right. So, but yeah, if you're throwing a 32-bit RISC-V binary in, I use auto detection for it. But if I know it's 64-bit RISC-V, I'll override it. And there's probably other cases where you might want to override it. And then the advanced settings. So for those who haven't read the blog post,
oh yeah, actually, do you have? I can show it on screen, or I don't know if you want to pull up the blog post. I can show that briefly too.
Yeah, it actually might even be easier for me to pull it in frame.
Yeah, I think right now I'd have to manually add your audio.
High-level graphic.
Yeah.
So at the core, basically how this feature works is...
Sorry, did you pull it up into frame? Because we just see Binja, if that's your intention. Okay.
Not yet.
No, you're good. Yeah, you don't have to now. I was just making sure that I wasn't missing something.
This is kind of the graphic I wanted to show.
Yeah.
And so there's a lot of open source tools out there that take a similar approach. And we kind of have our own special features within it and kind of iterate on that approach. There's a couple different approaches. There's like the scanning brute force approach, which is what Base is taking right now. And then there's also some other approaches that instead of scanning, it'll try to, like I've seen like different mathematical algorithms that are used to find like intersections between discovered pointers and spit out some candidate base addresses based on the intersection of discovered pointers. And what I found is that in testing and in evaluating these open source tools and then writing a prototype ourselves is that the scanning approach tends to be more accurate. No surprise, you're able to actually try out like the pointers that you discover. Do they actually line up with strings or functions at each base address, as opposed to, oh, I discovered 60 pointers. Let me just see where the bits within those pointer values line up and then treat that base address as the base address.
But a trade-off is then you're going to be a little slower, right? If you've actually got to do your analysis and evaluation each of those. So do you care more about accuracy? Do you care more about like a sort of quick and fast?
Yeah, that's exactly it. And the problem is like there's when you go that fast route, there's really not a good way to quantify confidence. Like say, hey, like analysis thinks that this is the correct base address.
It's an all or nothing. You either find some common set of bits or you don't. Yeah.
But it's based on intersection of a bunch of values that we don't know whether or not truly whether they're pointers or integers. And so some of these tools, you get really wild guesses with certain firmware samples. But for firmware samples that are the right firmware samples for those solutions, it spits out an answer pretty quickly. So yeah, as this feature evolves, I wouldn't mind
another mode of operation
sort of fast path, like, hey, while analysis is crunching, like here's some base addresses you can try. Or maybe if you're using the headless API, just I don't want to do scanning at all. Just give me a quick guess, and if it's wrong, I'll find the base address myself. But because the scanning approach was more accurate and took a little bit longer to implement, a little bit more complexity with it, I chose to get that core in place, and then we'll iterate on it if need be. And it works fairly well for most binaries. The binaries that take the longest are the larger binaries. That's true probably for about anything when program analysis. But and honestly, a lot of times the thing that takes the longest is just the initial analysis. So yeah, at its core base, the way it works is it starts by running Binary Ninja's initial analysis. And you can tell it to run full analysis or basic. The heuristics operate on low level IL. So really all it needs is a linear sweep, the ability to pick up strings and some data variables and lift functions to low level IL. So basic analysis works in most cases, but a lot of times full analysis is even better, even though we're looking at low level IL, because it does those additional analysis passes that promote like integer values that are pointer width. Sometimes it's able to tell like, yeah, this is actually a pointer, and it promotes it to a pointer type as opposed to
yeah, it's up to the architecture author in terms of the lifting. Oftentimes they'll do that.
right.
We have one quick question, by the way, from chat, where Valgrind says, as the resident retro machine guy, I assume it mostly isn't needed. But have you found any cases where BIOS or similar is required to be loaded to get enough pointer matches? Some Commodore 64 programs are chock full of kernel calls.
Okay. Explain that again. So in the context of the BIOS, is that what we're talking about? Like on Intel?
I don't understand. Well, then they're specifically saying some Commodore 64 programs are making kernel calls. I'm wondering, you're saying that the it's not like you have immediate pointers in memory because they're actually going through some loader or something? I'm not sure I fully understand the question, Valgrind. So if you can clarify in chat, but
okay. And Valgrind is the username.
Valgrind, sorry, yes, V4L grind is the.
So I heard Valgrind and my head started.
I switched you over to the wrong train of thought. Yeah.
Like, okay, so we're talking, like dynamic allocations and.
No. So I think my guess is they're just saying like, do you need like, are there cases where not having a like the sort of emulating a BIOS hurt you for pointer discovery? I think is what they're saying, and I don't know enough.
Well, so I mean, like, if you, I think dynamic analysis in many cases like could contribute to better pointer resolution. Runtime. That's like,
there's also indirect control flow where the pointers are calculated in a way that can be hard statically.
Right. Yeah. Like, however, like we're focused, of course, Binary Ninja is focused on static analysis, but like with that said, our possible values API does fairly well at picking up pointers that are computed dynamically in a lot of cases. But yeah, like if you have the ability to emulate that program and set a breakpoint somewhere and then query a register value, it's probably going to be more accurate than and pick up more cases. So yeah, but like it's running initial analysis, then it's iterating through all of the low-level IL instructions. And then it's got heuristics looking for specific instruction patterns where compilers like to, I don't know, load like the base address to a table of strings into a register. And then you'll see like low-level IL adds against that base address to reference different strings in that string table.
So Valgrind clarified and says that basically most of the pointers are not called to fixed addresses in like a BIOS section, and it's normally not loaded in Binge when they do analysis. I actually think your later demo is going to be far more relevant to that particular question. So let's keep going. Let's show off the base feature
Yeah.
and then we can. I think when we talk about the other stuff, it'll actually be even more interesting for what they're interested in.
Okay. Yeah. Before I demo it, so we're basically collecting a bunch of pointers, building pointer clusters, and then from those clusters, computing search ranges, and then from those search ranges, basically iterating through the search ranges and seeing how many pointers line up with strings, functions, or data variables within the binary. And that's kind of the too long to read of the future.
Well, and as you said earlier, a lot of tools only give you kind of a one-off answer. This can give you sort of the evidence behind why it thinks that is what it is, which is nice. So
Yeah, and
you
that's
get
the
like a
other.
priority order, not just like this or nothing.
Right. Yep. Yeah, and we'll show that a little bit in the demo. So what I have loaded here is an ARM v7 build of DOS U-boot, a common bootloader for embedded Linux platforms. So if I just click Start and run with the default settings.
I only recently got the joke, by the way, of Das U-boot instead of like U-boat. I assume is that where the comes from, or is it totally unrelated?
It might be, honestly, over my head. Um, so it immediately finished analysis and it threw out some candidate base
Their
addresses.
logo's a submarine, so I think I was right, by the way.
Well, now, yeah, today I learned as
Yeah.
well. I never caught that reference, and I've been looking at U-boot for 15 years. Uh, so, um, so this is actually the correct base address for this U-boot binary. In fact, like I can actually show you if I go to linear view, and here, let's go to map. I think it's, yeah, you can see I navigated it to it. So this is a perfect function that shows why the base address matters for analysis. So this is a function where this variable should be referencing a string. Instead, it's not file backed whatsoever because the binary is based at 0. So if I go back to triage summary and oops, here, let me rerun it.
Against the cache results, maybe.
Yeah, possibly. So yeah, you can see, and if I go to start full analysis and let it rebase, and so now that same function is here, and you can see like you get a lot better decompilation, a more accurate decompilation. So now that pointer that was there, that was computed,
Actually points at a relevant string.
actually points to
Yeah.
it.
And
Right.
there was
So
another change on DevRels recently that I think you might be able to show off too here, which in the upper right, the hamburger menu, the three dots, where the addressing on the left, you can now change. There says address display, third from the bottom. So just
yeah,
all the options in here are relatively new, just a couple weeks ago, and it made me think about when you were showing, when you rebase it. Well, now your go-to options are all kind of different, or if you had relative addressing, you can actually change. So your addressing is still relative to where it was at 0, and you can see those addresses. But you can also, yeah, there's a whole bunch of settings right there, and part of that is like if you're in a debugger and you can even like pick an address and make that the fixed point that all the relative addresses work off of. So there's
yeah.
a whole bunch of different settings in there, which I think is super useful. You even mentioned you had a couple of use cases when Glenn was working on this, right? That this
Yeah,
might be
yeah.
helpful
When
for.
immediately my head went to stack exploitation as being like the best use case for that feature. So like if you're writing a ROP chain and maybe like and you're able to leak a pointer within the binary, you can actually anchor and like go up here, go to address display and do from fixed base address. So like say the pointer you leak is that might not be the one.
I think you can just do from here or whatever.
Yeah, well, you can do from here, but you can also, there's one of them actually prompts you for an address.
Oh, I think
Uh,
it's just that one right there. Set fixed. Yeah.
yeah, yeah. So you can set the base
Yeah.
address to be something else, and then it'll display each
Everything
address
relative to that one.
yeah, relative to that. So like if you're writing a ROP chain and you're able to leak a pointer that points somewhere in libc, and oh, it's pointing to I don't know, some
Memset or something, and then you would want
set,
to find the
like
mem copy. You would
yeah, or you want to find system,
system, yeah.
like, oh, systems relative to and then yeah, not only that, like if you're just trying to understand uh like how much data do I need to overflow on the stack to overwrite the return address on the stack. You can make it's part of that feature that landed. Like you can actually show. I think he made changes to the stack view too. Um,
Yeah. If you actually bring up the stack view
yeah,
to the
yeah.
sides,
So uh,
yep,
yeah, I can't remember if it were
yeah. Choose base register,
yeah,
choose stack for base offset, all that stuff. Yeah,
right.
there's a bunch of
Right. So
improvements there.
value, you can make it based on some other register value too. So um, say going into an overflow, you control 2 or 3 other registers. So in my mind, this is a great feature to help with blockchain development, and I'm sure there's many other use cases that I'm not even thinking of.
So those features are all on dev right now. We've got the improvements to like the relative addressing, the stack view has that changed, and then of course your base. The feature which we almost didn't name that with the last minute, we're like, oh, we backnamed it into BASE, so base address scanning engine or scan engine. I forget what the official.
Yeah, base address scan engine.
Uh,
Yeah, if you're looking at the API, the class name is base address detection, and we decided that that is not a great acronym.
Bad
So
was maybe a bad name. So yeah, so there's still it's still vestigial. There's still left over in the API. You'll see it's still hinted there, but before we put it in the blog and we wrote the docs, we did that. So okay, that's a feature like I said everyone else has got. But what do you have that's new and interesting for us that we can check out?
yeah, so yeah, I can show. So we're good on base. You want me to show the?
I think we're gonna base on this. Is something else that you wanna highlight? You're welcome to.
No, I'll just whip through these real quick. If you I guess I just want to show on a 64-bit binary, and that's the thing. If people are familiar with using the open source tools,
Mm.
most of them don't support 64-bit with good reason, because the scan address space is much larger, and that's where like the clustering algorithm that we went with um, does a really good job of scaling back that search space. So this is actually another bootloader, but it's like an Apple iBoot secure ROM, and again, you can see that it was able to correctly uh, come up with the base address. And then one last thing before I switch over to the other thing we want to show. So inside of the examples, inside of the Python Binary Ninja API examples on dev right now, there's a script that shows how you can use the Headless API. It's all documented as well, but I've always thought like just looking at an example script is the best documentation. So the script is called raw binary base detection.py, and you can actually run it against a binary, and it's got chatty debug output that I could disable, but I'm running it in debug or with dash debug right now. And you can kind of see under the hood what it's doing, but it spits out in JSON format all of the
Sort of
information.
evidence the
Yeah,
things that justifies
right.
that.
So one of the APIs that are exposed in the class is not only um, it tell you like how many function hits, how many string hits, how many data hits at each base address. It also tells you like at each base address what were the reasons. So you can see like what were the hits. This pointer at this base address, this pointer pointed to this offset inside the binary, and type of point of interest is a string type. It's type 1 is. It's an enum that we have documented in our documentation. So this is just an example script that demonstrates how to use that API if you want. Like, hey, it's giving me some really wild guesses that aren't accurate. But the point of all of this is like this feature. It's not always going to get the base address correct, but my hope is that one of the 10 candidates are correct. And if they aren't correct, then there's settings that you can play around with. And then also there's additional information you can fall back on. So if you have to inspect manually that, oh, it's this pointer, I should look at this offset in the binary because there's a pointer that Binary Ninja was able to resolve that's pointing to it. And if I look at that pointer, maybe there's other pointers around it. And from those pointers, I can come up with the base address manually.
Yeah, so even when it fails, it can accelerate your workflow.
Right. So yeah, this is just the start. There's some, like I said, the other features I'd like to add to it, other nice helpers. And I didn't speak much to the advanced settings, but they're fairly straightforward. Minimum string length, lower boundary and upper boundary is another one. Like if you want the scan to go quicker, and for example, I'm looking at a Linux kernel, and I know the Linux, it's 32-bit Linux kernel, and that the virtual address space for the Linux kernel starts at OXC0000000. You plug that into your lower boundary.
You've just cut off 3/4 of your search space or more.
Right.
Yeah.
Right. So, and then same with this alignment value. The default value is 1K, but maybe like, oh, this is again a Linux kernel, and the page size on this Linux OS is 4K, and so my kernels, I know my kernel's going to be based on a 4K boundary, so up that alignment value to 4K. So
put that in hex, and it would look so much cleaner. You get it. You don't need the ON that way.
Yeah, I mean, or you can just
do it.
1,000.
Yeah.
So.
Very cool. Okay, so like I said, that one's on dev, and you test. Obviously, you got several different kind of bootloaders, ROMs, things to test it on. However, part of the reason it's on dev, we would love other people to try it and give us feedback. So if you find something that it doesn't work on, and you can share it, please let us know, because if there's features we can add or testing, tweaking we can do, sooner the better. So hope it works well for people and it saves you time.
Yeah, this is one of those features for sure that there's always edge cases because compilers like to do different tool chains, like to do different things for computing pointer values. So if there's other patterns we're not picking up or whatever else, especially if you're willing to share your binary, it'd be really helpful. All right. Let's go.
So then, and just for context, almost at like the broader picture, that we're really focusing on embedded applications. So there's a couple of members on the team that right now are doing research specifically on improving reverse engineering for embedded targets, and so that's why you'll notice. Brandon is one of the many people doing that. There's several other ones, so you'll start to see some features that are specifically focused on that. We're not forgetting everything else. We're still doing all of our general decompilation improvements. In fact, we'll talk about some of those after this. And we still have as a high priority kind of like some of those things like iOS shared cache, kernel cache support is. We don't consider that necessarily embedded, but some of the features that are coming, you'll see, are also part of the prereqs towards those as well too. So it's all kind of building towards that. But then there's like a separate set of stuff that's just how do we make firmware analysis better? How do we make embedded analysis better? So if that's something that you do a lot of and you have ideas, definitely be letting us know. But I'll let Brandon resume the show and tell.
Yeah, so the next thing I'd like to demonstrate is a new plugin we're developing. We call Firmware Ninja. And the way it's integrated into the UI is through a sidebar widget. And so this icon right here, if you click Firmware Ninja, one of the first operations that you can select, or in this case that it jumps straight to, is scanning for interesting chunks within the binary. What I have loaded here is a NOR flash dump from a Hackasat platform. And so you can see, like, within this binary, it's found padded regions. On the back end, I'll add, we're using the Unblob API. If you're not familiar with it, you can go to unblob.org. It's a great little project, similar to Binwalk, but
A little more
a little
modern
bit
in
more
design.
recently maintained. Yeah. And so within this binary, you can see it found these different types. You can also go to extract embedded files. And just like, if you're familiar with using Binwalk or the unblog command line utility, it is extracting these files on the back end. And you can iterate through these and select files that you'd like to load into your project. So in this case, I'll load, there's a flattened Linux kernel device tree. fwjump.bin is an open SBI bootloader. And we'll also take the Linux make configuration build file and the Linux kernel just to demonstrate some of the other embedded features.
Now, is it Unblob itself that already identifies that that's a Linux make config build file, or is there something else that?
Yeah, no, Unblob identified that.
That's pretty nice.
Mm-hmm. Yeah, so if you click import, it'll tell you, oh, you imported these files into the project. You can go back to the project browser. And we'll go ahead and load the bootloader. For now, well, yeah, here.
So it detected that 32-bit RISC-V.
Yep, and that's actually correct for this binary. And now I lost my window. I'll just go ahead and plug in the base address for it.
Now is the base address. We've gotten the other, other demo of, like, say we, ran the base detection. We've already kind of done that.
Yeah, right. Like, I could have ran the base address detection there. That was one of the binaries I was gonna show.
Yep.
Yeah.
In the interest of time, we don't have to show doing the same thing again, succeeding. Like, yes, we tested these files; they works on all of them.
Yeah. Yep. That's not to say you won't find files that it doesn't work on, and hopefully you'll share those with us.
Yes. But hopefully, again, even if it doesn't too, the fact that you get all of the candidates and the sort of evidence, for it, and, like, the information, hopefully it still makes your life easier.
Right.
If it isn't right.
Yeah. So another feature of the Firmware Ninja plugin is you can ask it to find possible memory mapped I/O accesses. And again, what this code does is it's analyzing, in this case, medium level I/O instructions, and looking for patterns that could indicate that regions of code that are accessing memory mapped I/O or hardware peripherals that are at physical address locations. So in this case, one of the best heuristics that I've found that for picking up code accessing MMIO is code that is using memory fences or memory barriers. So if they on, like, certain CPUs have relaxed memory models, and so in order to keep data cache coherency and making reads and writes be honored across multiple threads, functions that need to atomically access MMIO often have memory fences or memory barrier instructions. So handling those, recognizing those, another heuristic, whenever there's code that's repeatedly accessing.
Yeah. When you're in a while loop, the memory value must be the same thing or never the same thing. Like, that was something what I was like, oh, as soon as I saw that, I'm like, oh, that makes sense. It would have to be, it's either a spin lock where it will never return, or else it's waiting for a piece of memory to update, which can only happen with multi-threading or with something like, there's something else going on there. So I thought that was a really cool idea. I had never. I mean, it makes sense in hindsight, but it's cool that it like automatically looks for those sort of patterns.
Right. Right. So in this case, like it also orders them by most likely of having code that's accessing MMIO. And then for when it's able to resolve the location of potential MMIO accesses or regions in physical memory where hardware is mapped in, that's what this table shows as well. Another feature of Firmware Ninja is it handles certain file types in special ways, one of which is the flattened device tree that I imported into the project. It will actually deserialize flattened device trees and stash a bunch of information on the device tree about the hardware in project metadata. And then this is the kind of the device tree browser, if you will, that shows in the context of this platform. Um, these are the regions that certain devices are or reside at in physical memory. Or in this case, yeah, this is where memory is
Actual
at.
memory, yeah.
Yeah, actual memory is based at this address. OpenSBI is reserved within that memory region or within RAM at this address. You got a sock controller and interrupt controller. We got two UARTs here. You can see where their start and end is. And that's where you notice this function.
Mm.
These accesses are in this region of this UART. And so another feature that just landed on dev and that we're still kind of working out some of the rough edges on is adding memory regions
And
to
this
the
is what I mentioned earlier. Valgrind was talking about loading that BIOS and accessing a region of memory that wasn't there. I said, hold on to that thought for exactly this moment, right? Because this has been something people have wanted for a while. We've had an issue called like, non-file backed memory regions. There's been a couple different names for it, but in like the fact that we can now actually like create arbitrary regions of memory far more easily is super useful. So like that's the capability here that we can now leverage. So again, to recap, this plugin is not yet available for anyone to test, but the previous demos that we were doing are, and this capability here, where he's about to show off, you can do this right now on dev.
Yeah, I think it's if you do
memory_map, yeah.
Yeah, memory. Uh-oh.
Oh no, demo gods are cursing us. Yeah, we've.
No, I expected this. I'm really locked up. It's like my whole system. It's not even Binary Ninja. That might be cool.
Right. Oh, it's the Qt bug you're running into.
Yeah, the Qt bug is trying. Which is why I started it in a debugger because I was hoping
to catch the stack trace.
Yeah, I wanted to get that back trace.
You got it in scroll back. So exactly. Okay, good.
Yeah.
Valgrind, are you saying that has never happened before? We never crashed on stream? Because I know I have, but or maybe you meant Pizza Boy's comment about joining the Slack.
Yeah, well, I'm also running a local build of Binary Ninja.
This is an actual local dev build with some other changes
like that I've been hacking up. So
it's totally fine. That's what, in fact, yeah. Brandon even brought this up earlier, and I was like, it's fine. I have no problem showing this up.
Probably like my bug inside of the plugin that's not released yet.
That's quite right. So yeah, so the new memory map APIs, like I said, those are actually on dev right now. If you open it up, you'll see, we've had the segments and sections model in the past where like stuff was mapped. You could think of memory map as almost like a higher level abstraction. So segments are like the physical memory mapping. Sections are like useful annotations that can live on sort of top of them. But then the memory map is like a higher level thing than even the segments, because you can actually have multiple layering of kind of memory basically. It made sense when we drew it out on the whiteboard and we were looking at it. It among other things, it's also going to fix, in fact, the discussion we literally just mentioned, I said to join us in Slack to talk about Pizza Boy. We in in the debugger right now, if you're in debugging something and you like name a function, sometimes that change will just go away. And the reason it does that is because there's sort of like the debugger view where we copy the binary and all information about the binary that we have into the memory of the debugger. But it's not actually like synchronized. It's just like kind of like a one-off copy. And so you can switch back in the view type up top. You can change that drop down from like linear or to debugger, and you go back to linear, and then you can make your changes there. But it's kind of annoying when you're debugging to have to do that. This new memory map system solves that because it basically overlays the actual binary view where all the analysis is happening and where user changes and annotations and you're making all your stuff happen on top of the view of memory that the debugger provides. And so that gives you the best of both worlds. You don't just like have like this one-off copy that you have to throw away. It means that you can interact with the binary, you can have the debugger in the backend and all the other addresses and live memory that's pulling off the debugging engine, but you can also then make changes and annotations that will get serialized and saved into the database. So anyway, this is this brand new feature called Memory Map. Like I said, it's still kind of in testing in development, but it's going to enable both this debugger improvements and a lot of other neat stuff. Like so, you can see this here. We can see data about the memory map and how it's configured. But the cool part is though, if Brandon goes back to that device tree, right, we've actually got like memory mappings that are specified, and he can actually like just by double clicking one of these, it will actually create that memory for you. It doesn't have to be file backed. It doesn't have to be existing. And you can actually pass in a
Yeah,
OBS
no,
Studio disconnect.
yeah,
OBS
no,
Studio disconnecting, reconnecting. What's going on?
I can still hear you. Can you hear me?
I can. What happened? Reconnection successful. Okay. I was afraid like Windows was pulling a Windows and was going to reboot itself on me. I have actually paused updates because there was an update going before I started the stream.
Yeah, now that bug is starting
Still
to really rear
streaming.
its head.
Somebody in chat, let me know if we're actually I can pull up the stream just make sure we're still streaming. All right, I think we're still here. Yeah, we're still good. Okay, that was really weird. OBS scared me. Yeah, no drop frames. We're good. Okay, so yeah, so we've got a bunch of new features in this firmware plugin. You do need so again, the plugin itself is not yet public. We're still trying to figure out if it's going to be. It might actually be a separate paid add-on for another version or maybe an enterprise. Okay, cool. Background. Apparently, yeah, I don't know what that was. It says there's even no drop frames. So we're still kind of trying to figure out the details of this. There may actually be like but what we might also do is we have currently the nanomips architecture that we have as like a separate architecture from our normal like everything's included kind of all in one. We might actually have like a separate kind of bundle of both a couple of architectures and firmware specific plugins. We'll see. We're still trying to kind of figure that out. But as always, anything that we do that is separate will have lots of it, and most of it will still be included in the base version. But what I was going to point out too is that the project integration, where you actually pull out all the files into a project, only commercial and above versions of Ninja have projects. Yeah, Valve Grind, absolutely. There will definitely be a blog for the memory map. The only reason, like I said, I don't think we've done that yet is we're still kind of working on it. We've got this plugin here is one of the first sort of visible usages of it. But having a sort of better integration in the UI, having the debugger integration, there's a couple other things that'll come out with it. So it worst case, it won't have its own dedicated blog, but it will be a major section of the 4.1 release notes. So at some point, I guarantee you there will be a blog covering it. Maybe we'll get it out before the 4.1, or maybe it'll be a part of the 4.1. And then of course we're gonna write up the documentation on it too. So yeah, we'll definitely get that out there. So any other features in Firmware Ninja you want to show off, Brandon?
Well, I think about that. Well,
So you basically just by double clicking those devices, you're able to actually create those new sections, and so now you have like cross reference. I saw those two variables show up where you actually got cross references to variables.
yeah, right. Yeah, I mean, all you got to do is click on these devices inside of the device browser, and it'll create those sections for you.
Super nice.
Yeah, and then other than that, other special file types too, like a lot of kernels will compress and include their Linux build configuration, and so when we're able to extract that, stashing that in a metadata, project metadata, or the Binary Ninja database metadata. What we're doing here also with Firmware Ninja, I should mention, is everything I'm showing here in the UI. I'm also um, either in the process of or currently it is stashing it in the project metadata. And why we're doing that is so that we can write a sidekick indexer script that's also be able to not only look at the code that you're looking at and
But
provide
all that
insight.
extra context. So if you ask
Yeah,
Sidekick a question, it now knows also about all the device mappings and all the kernel config and
right.
it's way more context to answer questions. Yeah, it makes sense.
Like that function that we showed that was accessing that UART. Well, it's 3 lines of high level IL code, and so it's like you ask Sidekick about it, it's going to say, well, yeah, it's repeatedly accessing a
Yeah,
memory region, and that's all it can tell you about it. And
yeah.
but if you give
Maybe
it,
it gets lucky and infers that pattern could only exist if it was MMIO, but if it has
yeah,
the
yeah, and it
specific
actually
memory
will
map
do.
already, yeah.
It's it's been impressive
But
for
specifically to have the memory map as part of the context would be
yeah.
Peter's also asking if we can get a blog post on the memory map of Brian. So he's asking in the chat too. It's always fun when we have others in the company watching the stream.
Yeah, and tasking people through the chat.
Yeah, yeah. This is your assignment via Slack or via YouTube chat.
Yeah. So,
Awesome. Well,
um,
yeah, great work. And again, if other people have questions or suggestions about the features, again, ideas, there's a lot of. I was already impressed at the stuff, but I think it's because Brandon's done a lot of this embedded RE. So, uh, Glenn also loves hearing about. I think we have the whole company watching here, which is fun. We're probably over half the view count currently on the stream. So, uh, yeah,
I'm glad.
I really was excited about all the features that you've relatively quick time kind of thrown together. So I look forward to seeing the new things that make it into Firmware Ninja.
Yeah, thank you. Yeah, if anyone has any ideas too for other features they'd like to see specific to firmware analysis inside this plugin, or just wants to talk about embedded firmware reverse engineering, it's ZZ Nop on the public Slack. So,
Sweet. Thanks, Brandon. All right, I'm gonna go ahead and switch over, and then I have to lean. My Stream Deck didn't work when things came back up, along with the timer. I'm not sure what was up with that. So I'm gonna close out from Brandon, and of course the desktop went away. Why would that not still continue working?
stop sharing if that's what you're.
You are. Let me actually kill that section with you because you're still there. I think if I close this, and all right, I think we're done. So hopefully I disconnected him, but now I got to fix the desktop. Figure out why that one went away. Desktop capture. Yeah, like all the USB devices apparently. Thanks, Jonathan and Valgrant. I will pass that along to him. Um, we'll make sure. All right, maybe one of the other 4Vector35 people who are in the chat, we can. Well, yeah, we'll let him know if he didn't hear it. And yeah, Brandon's doing some really cool stuff. Like I said, I'm looking forward to people trying out that base address detection. Let us know if you have, if it works for you. Let us know too, and let us know if it doesn't, and we can hopefully make it better. Mohammed, intermediate trainings. That's a good question. We do have just in general all of our trainings are on the website, and if I spell it right with one S, we don't currently have any listed courses for the intermediate. Actually, that's a good point. I think we do have plans. I know we do have plans to do one later this year. I'll ask Kyle to post the exact dates. I don't think we have. So the intermediate class we've found doesn't do as well at conferences. I think people who go to conferences want to take the advanced stuff. So we're doing more of our PAVR class with margin for conferences, but we do expect to probably have another intermediate class. But we will also be at Recon. Speaking of kind of in the news and what's going on again, yeah, we'll have a whole bunch of people at Recon. So if you're there and you want stickers, or there's also the offer I always make. If you want us to carry and hand deliver one of our awesome store items, we can do that for anybody at conference with no shipping costs. So it just goes in our luggage and we bring it. So we'll see. Yeah, just let us know if that is the case, and we can set you up with that. Training there. All right. And again, here's the blog post as well. Yeah. So if you just go to binary.ninja and hit the blog up, another item on the blog that I want to mention just went live is our first major security issue. I think this has been 9 years as a company, and we've got to explain a potential security exposure that we had. Thankfully, like no user data, nothing super crazy happened. Actually, it's more of an impact to us. People could have gotten free Sidekick, basically, was what could have happened. The long story short is that the way that the API system worked, or sorry, the way that the settings API worked in particular, was if you registered a new setting, and you didn't have this part right here where you have this ignore field in this basically says what can a setting apply to. So like when I open just like a file, there's like several different levels of settings. And so you can actually see user, project, resource. So projects are like the collection of files like in a project. Resource is a single file. So like for this file here, I can actually change settings that apply just to this binary view. Same thing as like when I do open with options, right? If I do open with options on a file, that's letting me change the settings just for that file. And when I save that file, the settings are all serialized and saved with it, which makes sense. Like if you share that file with somebody else, you would want the same analysis settings, or else they would get different behaviors. So it's important that that data kind of gets serialized with it. But the trickier part is that if you just make a setting that's more of a user or a global setting, but you don't exclude project or resource scope from your ignore setting, what would happen is that setting will just be included anytime I save a BNDB. So the vulnerability was basically this: your API key in Sidekick, which I actually don't have Sidekick installed in this box, so we actually can do it real quick. Let's show it off. It may take a second because that's got a lot of dependencies, but we'll kick that one off. Sidekick, when it saves your API key, it uses this new kind of hidden API key field, which will let you have that setting show up in settings, but it would not be visible, like it masks it out to keep it hidden. But it didn't specify this resource scope. So long story short, you saved a database, you shared it with somebody else, your API key could be in the database and they can extract it. So we've fixed this in a couple of different ways, and we talk about it more in the blog post, as well as I think, yeah, the Sidekick documentation page talks about it. Essentially, we've just invalidated all of the API keys. We've updated the plugin with a version that doesn't do this, and then everyone can like log in and go to the Sidekick webpage and get their new API key to kind of reset that. So no user data was exposed. You couldn't have like, even if somebody had your API key, they could have just used your tokens, but because we just refresh them anytime anybody asks anyways, it didn't really hard stop anybody. And as far as we know, nobody else discovered this in the wild. It was just something we found. But there is also the impact that other users or other plugin authors, like for example, I've written, if you remember on stream several months ago, I actually was writing a plugin that would let us download files from like a malshare, right? I don't think I have that plugin installed here. In fact, is that, I don't even know if it's in the, oh, there we go. So now we've got Sidekick installed actually. So if I open up my settings again, and I search for Sidekick, you can see like if I type in my API key, it becomes masked out, right? And so if that was my real API key, it would get saved into the Binary Ninja database. Yeah, exactly, right? Free API keys. All you had to do was have a friend who had Sidekick who was willing to give you a BNDB, and then you could have gotten free Sidekick. So sorry, everybody, you missed the chance for that. But we also were worried about other plugin authors not knowing this. So the other change that we've made, in fact, I think it's going to be, oh, we need to update that blog post. That reminds me. Brian, if you're still watching, let me know the build number because I think you're pushing your build, your change, and we need to update that field there. We'll put the exact version number that the API fix is going to go out with. But if a plugin tries to register a hidden setting, like one of these in particular, but they don't specify the ignore scope, it will force them to, oh, I got an update, yeah, for installing Sidekick. It will force them to pick an ignore scope. You can make it empty, but you have to have an ignore scope. So it sort of requires a more kind of conscious mistake to happen. Now, it is worth pointing out that there may be other information in your settings, like I believe like PDB information, like if you specify an external PDB source, it will be saved into the BNDB. So we do have another issue tracking like a sort of new feature that would be nice. In fact, it's worth just mentioning to people. If you, in general, sharing a binary integer database with somebody else, I highly recommend using this save database with options because you can like remove a lot of this extra information that exists into it. So like if I save my analysis database here and I put those to the desktop, and now I've, and then add some names. I put in this kind of information into here, and I've saved a bunch. I may have like a really big database with all of my undo history, which fun fact, by the way, this is all now visible. So there's actually a history doc widget, another new change that just happened this week. The site, by the way, Brian, the Sidekick stuff is already pushed, so you can go live on that. Sidekick server and plugin went live last night, so you're actually good for that. In fact, yeah, we can actually test this. Let's actually look at this. If I actually query my settings, I should be able to see this. Deserialized schema, is that what I want? No, there's a way just to get the settings all dumped and serialized schema. Yeah, so I could just take this, and I think this will this show me all the properties of it. If I look in here for Sidekick, I should be able to see that it now has the proper scope. So let's try this. This is a good test. We'll make sure we did indeed get this done right. So if I take that, and I think I don't have Sublime in this box. I usually keep it on there. No, I can't do it. Can't do it. Give me a terminal. Maybe terminal is a little bit of a bad choice. That's all right. So I should be able to look through here and I should find the API key and it should, oh, you know what else I should do? Actually, let's do it even better. That was a lot bigger than I expected. I bet this is just faster. I should probably just do this. Use the UIs of the terminal and then save as text. Wait, really? Text edit doesn't have a plain text thing? I'm so confused. There's no text editor built into, see, this is why I install Sublime. It might actually be faster. I literally have a copy of Sublime just for like streaming stuff. Oh, there we go. Okay, we're done. Oh, I thought it might be, all right, Python 30-mjson.tool, test.txt. No, I had an extra quote at the very beginning. Oof. Is it just one long line? Oh, that's why. Oh, wow. Yeah, I'm not sure what escaping is going on. Okay, we're just going to edit this file and we're going to look for API key. Yeah, there it is. That was it. So setting API key, default description, it's in the group Sidekick, hidden true, ignore. There we go, resource scope. So this was essentially the flaw, was that resource scope was not in there, and so it was getting saved in the database. So we can see now that is fixed, so the new version of Sidekick is good. So Akalon, welcome. First of all, I don't know if I've seen you on stream before, but let me see your question is, why does the architecture class return center string for everything you register name? So you're talking about like the C++ API? Like if I have an architecture dot reg, you said dot registers? No, it's a dots regs. I think it's, wait. I don't know that it should. Like this, you'll notice doesn't return strings. So I don't know as much about the C++ API in particular. 100 megs for rack string kind of is a lot. Yeah, I'm not sure. Okay, well, good. Peter's here. He can answer your question better than I can, anyways. Yeah, but just as like a brief summary, basically. Oh, I just realized my lights are off. Oh well, I'm in shadow today. Yeah, part of my stream deck being weird. Because we support Rust API and a Python API and C++, lots of stuff goes back and forth across that API. It has to have some format. Yeah, it's okay. That's a new feature that's really nice. This little history thing. Um, yeah. So Echelon, I'll let Peter answer. If you have more questions, feel free to ask him in chat. I'll let him clarify because again, he'll have a much better answer. But the history feature is nice and lets us also like undo back in the stack. We can see when stuff happens. It's kind of a nice feature there. So, but if I've done this now, if I save the analysis database with options, this will let me remove a lot of the undo history. So in fact, I think if it does that, it shows just a flattened, like if I reopen this file, yeah, that history is gone, right? We don't have that history information. Whereas if I hadn't done that save with options, it would still be there. I'd be able to see the full history of undo actions. And so it's super nice that that lets you prune it. However, you'll notice there is not the ability to like remove settings. And that's something that we're thinking about, pursuant to the recent issue, right? We'd like to have the ability to maybe let people prune some of the settings, and it's a little bit tricky because the problem is, as I said earlier, if I've done changes to my analysis and my settings are different than yours, and I give you a database, you'll get different results, right? If you're not using the same analysis settings that are saved kind of into the database. And so we don't just want to like remove all settings. It'll be a pretty big foot gun. So we're trying to figure out the best way forward. We'd like to give users the ability to like really make sure they have removed things that they think could be problematic. So we'll probably have to build something a little more complicated, like a UI, or let people remove anything that contains like text fields. I don't know. Yeah, we haven't exactly solved that. But if you're curious or concerned about that, you can see that being tracked over on, oops, not that page. Nope, stop popping up, GitHub. On, yeah, these two ones here, as well as binary view metadata. So you can actually, plugins can state stuff in the metadata. It's not necessarily something you would see here, but if you wanted to exclude that, we would like to give people a little more control. So we'll probably get a couple more options in that dialogue to clean things out. Okay, so that's the kind of generic news. Now let's go to something more fun. We've got, yeah, exactly, Kay. A lot of people don't know that information exists there at all. So even, for example, bv.original, original file, bv.file.original file name. Yeah. That's a field that can have the full path on it of the file itself. And that's also stripped out when you do that. It removes the full path information, right? So you just get the file name itself, but you don't have any of the full path, which otherwise would have been in there. And on your box, on your machine, if you open a file, it's useful. Right? Like if I open this thing up and I have a plugin I want to do something for it, it's kind of nice to actually have so like if I save this one, for example, and make a new database, this database, and now I access that BV original file name, you'll see it's got the full path to it. So again, we want to make it so that it's convenient for you as a user, but we don't leak things. If you share with others, you should have the ability to strip that out. So, all right, let's talk about this particular test branch. So Rusty has been working on some really fun stuff. Internally, we're all like gleefully watching the changes he's making because he's doing some really cool improvements to binary control flow recovery. So just in general, like if I open up the dev build of Binary Ninja, some of the problems that, let me actually grab, I think I've got a database here. But you know what? That's what I was going to do. I don't know why macOS doesn't make desktop a default folder. Where is it? Yeah, desktop. What? I can't. That was weird. Couldn't click there. Okay, that was weird. All right, so, oh no, I'm blind. Desktop is there. All right, try again. So this is just kind of this test case binary with a bunch of things, but like there's a couple of problems with this. You'll notice like this super deep nesting tree and the structure really hurts readability. And so just in terms of like general problems we know Binary Ninja has are conditional simplification. We have these long conditionals sometimes. Another one is if you have like really deep nested trees and you have long conditionals and you'll have like a function call with a bunch of parameters in it. It can be way wider. Like you have to scroll like right to left more than we'd like. This one's not super complicated. It's definitely a more minimal kind of test binary. But you can see this is kind of the current behavior. And in terms of decompilation quality, like this is not bad. It's not like outrageously awful. But it shows off fairly nicely what we're doing for the improvements. So if I open that same thing in this new, now I think it's a setting. I need to double check here. Actually, I should have checked with Rusty beforehand. Let's see. Yeah, this is it. Oh, I guessed right. Okay, so this is the setting, and I think another thing we're debating is this may get shipped onto dev as the default, or it may just get shipped as the dev turned off by default and let users decide. So again, this is a test branch I'm looking at now, but sometime in the next couple of weeks, this should be landing on dev. The current behavior is condition graph, but if I change to graph transformation, the idea is that we're letting Binary Ninja's high-level IL analysis try to rewrite the graph and transform it by duplicating things or adding edges or changing in a way that is still sound. So in other words, it is a valid representation, like these two things are both equivalent representations, but that in a way that we hope will let us simplify it and produce better resulting decompilation. So here is that same binary, and let's actually just go ahead and kill all of our kind of sidebars. And oh, I don't have my hammer spoon installed that lets me do things side by side very easily. So let's do this. So again, on the left we have our before. This is the current dev, which you'll see, and then on the right we have the test branch here. In fact, let me make sure it's not going to update me. Okay, good. It's turned off. And we can just kind of look around here. So we can see our main looks fairly similar. I don't think I see, oh no, I do see some differences, right? So this invalid choice here, for example. Yeah, right. That's right. This is a known case. So this is a case where, and this is why this is not on dev yet, is because this is one of the sort of regressions. And so you'll see when this is cleaner, this should be identified as the default case on the switch. And so, this is actually the current dev behavior is actually better for that particular case. So that's one reason we haven't actually landed this on dev. But small alloc, right? This was the behavior before, and this is the behavior afterwards. Oh, there's one other change that we're gonna make, I think probably on, let me show that one off too. There is I keep being distracted by my own video, so I've got the chat up on another screen. That every time I make a big change to the screen, hits my peripheral vision. So where is the rendering? Yeah, add new lines around scope. So this is one that I think we might change to be the default of 1. So let us know what you think about this change. But this is what it looks like when you add that value of 1. So any scope change will automatically add just a little bit extra white space. Which I think makes it. There's also the braces, like you could turn on, there's already like a braces thing that some people like because they makes them feel like they're looking at C, I guess. So you could do that if you want, but I personally don't like the braces, but I do like that extra new line to be there. So yeah, let's compare this before, right, where we have this behavior versus afterwards. So it essentially we're duplicating this return, right? By like noticing that we can have early returns here in like failure cases or like error checking, it produces significantly, and it's not just returns, right? Like any structure, like essentially where it can be better. You tend to see this a lot with like early returns. It looks just a much cleaner, I think. So we do, at the cost of some additional lines, right? We have like I guess a lot of that too is because I've turned on the new lines. Actually, if I just reopen this, it'll do it the same because I've added the new lines to scopes. There we go. So this is maybe a little more fair comparison if we do it. But yeah, still significantly kind of easier to read when we don't have this really deep nesting. So you get just a whole lot easier to comprehend and observe that like this behaviors don't necessarily need to be in a super nested loop. In fact, this is probably much closer to what the original source code looked like, right? So that's super exciting. I think we internally are really looking forward to that. seeing these improvements. Yeah, we can see the same thing down here too in this examine one. And this was an old CTF challenge, by the way. We didn't write this challenge. It was just one of the test ones we had sitting around as a kind of small size, nice one to do. And you can see the same sort of thing there versus this. Just a lot easier to have this early return um, and then flow through. So just significantly less depths where you have to worry about like how many levels deep of indentation am I at. The cognitive load there is kind of a lot higher. So like I said, there's still a kind of one regression that we've noticed around switch statements. We're doing a lot of testing to make sure it's sort of a superset where it's always producing kind of better results. But that's really exciting. I think that plus just in general, there's like one other one that we have slated for this next release to just deal with like long wide lines in general. Like I said, sometimes you get a function with like 8 parameters and it can always go off the screen. So having a better heuristic for like detecting when we should probably just line wrap that and shrink it up and put new lines in there. I think that kind of stuff will make 4.1, like the actual analysis isn't going to get any better, like necessarily. What we're really fixing is just making it display, really worrying about how to improve the sort of the last step from the screen to the human. Like how do we improve your ability to understand things and visualize things and see it, even if like your script working on the IL won't necessarily change significantly. Like it's going to do the same from a program analysis perspective. These are really things that we can just work on making it better for humans. So that's an exciting one. I'm looking forward to that. And yeah, Nicola Dev, I see Peter's already responded to you in chat, but the most of a bottleneck type inference, or it's a really hard question to answer because it kind of depends on what you're doing. I will say that I think one of our priorities as a company right now to make performance less of an impact on our users is keeping it responsive while analysis is happening. Like one of the things that we actually asked some of our customers a while ago, like, hey, we've got this new feature. Let's pretend that it improves the accuracy of our analysis by 30%, but it makes it take twice as long. Like, would you care? And they're like, no, absolutely not. Like this particular group of customers was like, absolutely, the most important thing for me is that you give me the best, most accurate, most readable, most whatever it was, result. And they they were like, I would happily trade. I'll just go get a cup of coffee. Like once I've got my database, I'm going to settle in and make a bunch of changes now, analyze and work with it. But like that initial analysis is actually not the most important thing. It's not as important as the accuracy of your results. And so that was interesting to us because we're really focused on like the performance. And I think part of the reason why is because if performance slows you down, like if I as a user and I open up a file and it's unusable and I can't do anything for a long period of time, that can be annoying. But if I can even browse around and it's usable and I can start looking at some things and the rest of the binary is still being analyzed, even if things are going to change because analysis can have like effects or whatever. That's one thing that we're kind of cognizant of, is that we really want to try to make the experience better even when you're under load or you have a big file or you have something that you're analyzing that can be slower. So yeah, just kind of a related a related topic in terms of like improving performance. And then Peter is also wanting me to point out, let's see, line FBA. Oh, yeah, exactly. The conditional complexity. So, okay, so not just, I mentioned very briefly that conditional complexity is going to be improved, and we saw that as a problem. But it's worth pointing out there's several things that have already hit. Let me just go to fix. Oh no, I'm in a different binary. No wonder. Why don't I see that one? So I think on this particular example, it didn't change. It didn't change the conditional complexity currently, but this is something else that that Rusty has taken a look at. And one thing that we have landed several fixes for are like other, like if you have not A or B kind of thing, right, is equivalent to A and B, if I remember my Boolean algebra correctly, right? Like there's or not is equal to not. Is there another not in here? I got to do whatever it is. Like actually, like this Boolean simplification step. There is sorry, I'll grind. Yeah. I know. we have a choice when we update the API. Do we force plugins to update, or how do we handle that? Um, but like, so there's a bunch of improvements in terms of simplifying uh, conditionals, but then also the analysis that high level IL does for control flow recovery of when to split things up, when to combine them, and when not to. That's something else that's getting improved, and so expect to see some improvements there as well. So, oh yeah, another little one even that went through is if you have like a equals a plus one, a plus equals one. That's another change that if you're on dev right now is already in. So if we actually find like I don't know if there is one in this binary. Yeah, there is right there. Exactly. So you can see like that's another nice little, just a little small readability improvement. Again, the actual like, current IL instruction, it's going to be the same exact assignment. It's just an assignment where the source is an operation as an add and it has a left and a right and a variable I and a one. Um, but like just that making it a little bit easier to read, a little bit cleaner. That's really kind of where we're focusing. I think we're relatively happy, honestly, with our overall like general analysis. There's always things that we can improve on. And in fact, even some of the like the high level IL control flow restructuring that's happening is going to improve analysis at the accuracy of the translations, and so therefore high level IL will be better for automation. However, really a lot of this focus now is like, okay, but how do we make this as readable, understandable as possible? Because I think that a lot of people view our decompilation quality as not as good as it could be, and a lot of it's just like this kind of stuff that's really straightforward and easy, and we can make it show plus equal one, and we can just put a little extra spacing around things to visually split things up, that we can shrink our depth, all of these things added together. I think people are going to be like, wow, your decompilation got twice as good. And it was really us just tweaking and tuning the presentation layer and like some optimizations and things, and not about making major massive changes to how analysis happened. But I'm super excited because I think it's going to be a really fantastic like, usability improvement. So I think people are gonna be hyped for it. So I was originally worried about 4.1 and some of the features, but I actually think we've got a fantastic list of stuff. So we'll have that stream actually in a couple of weeks coming up. I think it's 2 weeks from Monday maybe is going to be the feature release stream. So we'll talk more about uh, um, like the full set of features that are coming out. So I'll recap a lot of stuff that I've just kind of been randomly doing now, but we'll have the full list of 4.1 features then. So mark your calendars a week from Monday. Again, if you're on the YouTube app, you can make sure you turn on notifications or whatever, and you can get it there too as well. So awesome. Yeah, I'm about it for me. I'm gonna go and check out the rest of the team. Just as another heads up too, we are doing a small stable release. So we're doing basically kind of like just a service pack stable to get out. If you look at our our last 4.0, there's maybe 4 or 5 bugs that are pretty annoying for like a small group of people. So they're not um, major deal breakers, but like if you are in those use cases that they were kind of being blockers. And so because we're not going to have another stable release for still another like more than a month, we thought we'd just get a little quick one out. So this is something we're doing new that's a little different. We've done this before where like shortly afterwards we have done like SP2, SP1, whatever kind of release. And it's not going to throw off our whole release schedule. Like we're not going to suddenly turn into other tools that shall not be named and have really long release cycles with just a couple of small service packs. We still are going to keep the same. 4.1 is still going to be pretty featureful, and still going to aim for that 3 to 4 is been pretty rare, but three releases a year is pretty much the cadence that we've really been able to stick for a while. And so yeah, we're gonna get just another one of these out. You'll see again something just like this where there's just a couple of fixes and crashes and things that we thought were critical enough, and we didn't want to kind of hold off. In particular, I think the demo version of Binary Ninja is there was something wrong on, I forget, Windows or something. I don't remember the details of it, but we've had a couple of fixes to that we wanted to kind of get out. So that will help people that are using the free version, or sorry, not demo, free. I gotta remember it's not called demo anymore. The free version. Free's got a fix coming out. This should make it better. So, all right. Well, thanks everybody for hanging out. Yeah, lots of cool stuff. we'll see you, like I said, in about 2 weeks, 2 weeks and 1 day, because it'll be a Monday because I'm on vacation in 2 weeks. So yeah, it's good to see you as always. Thanks, Valgrind. I appreciate it. And I got to lean over because the Stream Deck's broken. So you'll see me off camera for a second as we do the outro. But take care, everyone. Have a good weekend.